All right, so what do we think about this situation? Anybody got a conclusion there?
Similar.
So yeah, dude, let's start with the angles. What's this other angle have to be?
60.
This one has to be 60. And what's this other angle have to be?
60.
This one has to be 60 as well because of the 180 total, right? It's got to make 180 total. And so, yeah, so are they similar? Yeah, they've got to be similar because they have the same three angles. We already knew they had the same two angles. That was good enough right there, right? So, yes, they do. They have the same three angles, so they are similar for sure. Now, what about congruence? So, again, I'm giving down here. So, for similarness, you use AAA. You can have two triangles. You can have two triangles that have the same three angles that are different sizes, though. They might not be identical. Similar means identical except for size. And then now, what about congruence? What do you think? Are they congruent? Are they fully identical? We know they're similar. Are they fully identical?
No.
How do we know not?
Because if you look at which angle is opening up to the side length of 5, in the first triangle, the 60-degree angle is pointing to 5, which is a medium-sized angle. But in the second triangle, the 90-degree angle is pointing to the side length of 5. So that means that in that triangle, the side 5 is the biggest side because it corresponds to the biggest angle. So you know that 60 has to correspond to a smaller side length.
Very good. Is that what y'all picked up at your groups? That's excellent. Yeah, exactly right, right? The 60 in the left triangle, in this triangle over here, the 60 is the medium angle. So across from the medium angle has to be the medium side. So that means the 5 is the medium side in that triangle, which means there's a side bigger than 5. I don't know what it is, but there's some other side, 6, 7, 8, whatever. And there's a side smaller than 5, 4, 3, 2, whatever. Right? Something bigger, something smaller. Whereas in the triangle on the right, the 5, the 90 is the biggest angle, so across the biggest angle, that's the biggest side. The 5 is the biggest side, which means the other two sides are both smaller than 5. So those triangles could not be fully identical, could they? Because the triangle on the right doesn't have anything bigger than 5, whereas the one on the left does have a side bigger than 5. I don't know what it is, but I know they've got different sides, don't they? So we know for sure they're not identical, they're not congruent, but they are similar. Is that good? That logic makes sense? All right, let's go on to number 2 here. And there again, I'm showing the small, medium, large idea. So same kind of thing. See if you can find all the angles. I'll give you a hint. That triangle on the left, you can find all the angles. Not the one on the right, but the one on the left you can. All right. So what do you think about triangle on the left? Tell me about triangle on the left. What do we know about those angles? Danielle. Yeah, what do you think about that one, Danielle? Yeah, this has got to be 65 also because they're both across from the same sides, huh? Right? Y'all getting that right? Across from the same sides got to be same. It's an isosceles triangle, right? Two equal sides, two equal angles. Good. And then, what can we do for the other angle? Yeah, the 180 thing, right? So just use your calculator. Or 6 5 7 was at 130. Subtract from 180. This one's got to be 50. So we got all the angles in the triangle on the left. Okay, now, are they similar? So we notice we almost always start by doing all the angle stuff we can. So now, for similar, we're asking, do they have the same 3 angles? We just don't know, do we? They might not. This is going to be a not enough information. Does that make sense? Because the one angle we do have looks good, right? The 50 and the 50, they both have a 50. If that other angle was something like 40 or something, then we'd right away say, no way they could have the same 3 angles because we already see a different angle, But it didn't. They gave us one that's the same. So it's like, yeah, so far so good, but we just don't know about the other 2. So we just don't know. Not enough information there to decide if they have the same 3 angles or not. They might not. Okay, then how about B? How about congruence, identicalness? Are they identical? Do we know we know for sure they're not? How do we know for sure they're not identical? Somebody new want to share? Anybody just dying to share? Woke up this morning, thought, I want to share today in math class. Yeah.
In the left triangle, the 65 angle is pointing to 3.
Right.
And then in the right one, it's the
Very good, right? Yeah, that whole thing we talked about right over here, across from the biggest angle, it's got to be the biggest side, smallest angle, smallest, medium, medium. Yeah, so this 65 is across from the 3, and the 65 is the biggest, tied for biggest angle. So 3 and 3 have to be the biggest sides. This other side has to be smaller than 3 in the triangle on the left, doesn't it? Because it's across from a smaller angle. So that triangle on the left has to have a 3, 3, and something smaller than 3 as his sides. And the triangle on the right, the 50, across from that is a 3. Well, and then over here across from the 50 is something what? Smaller than 3. So they could not be identical, could they? To be identical, everything's got to be the same. Same angles across from them, same sides. Yeah, so they're for sure. So we can actually say with confidence, they're not identical. Right? It's not we know for sure they are not identical because they don't have the same sides across from the same angles. We have enough information to rule that out because the 50, and it's got to be something less than 3 on the left triangle, it is 3 on the right triangle. And then the similarness, we just don't know. Is that good? So it's important to know even when you don't know. That's part of really knowing something, is to know when you don't have enough information. Questions, comments on that one? Are we good? All right. Let's try this one. All right, did we find all the angles in the triangle on the left? 55, 6, and so 55, right? Right? 2 sides, crossing them, 2 equal angles. So then the third angle, whatever it is, add 55, 85, what's that, 110? So it's going to be 70. We good there for the 180 total? So, okay, so we get all the angles in the triangle on the left. So are these two similar? And similar comes from AAA or AA, same thing. So do we know? Are they similar? Is it not enough information? Yeah, it just seems like not enough information, huh? There's just no way to know for sure. It's just not, they could be. They have, it's like so far so good. They have 2 6s, 2 6s. We just don't know anything about the angles on the right. In the triangle on the right, we just don't know. That's not enough information. We just don't know the angles, huh? They could be. How about B? Could they be identical? Could they actually be identical in every way? Again, could be. We just don't know. It's just that this one is not enough, not enough. It's like so far so good, we just don't know enough information, huh? They have 2 6s and 2 6s, so it's so far so good, but we just don't know the rest of the story. So yeah, not enough, not enough. Kind of a weird question. Does that make sense? We know like halfway towards both of them. All right, I'll move on. Number 4. Try that. Okay, so how are we doing? What's the missing angle here? 60? Got to be 60 to make 180. Missing angle here is 80. So are they similar? Are they congruent? Yeah, not enough information. Makes sense? Because they have the same AAA, so they're similar, but one might be, oh, by the way, you can't go by the looks on all, none of these look right. So we're just going by the facts. So they could be congruent, they cannot be. We just don't know. There's just not enough information given to decide. Right? We know they have the same 3 angles, but one might be a small version and one's a big version of the same thing. They might be exactly identical. We just don't know, huh? Because we don't know anything about the sides. Does that make sense? All right, on we go. How about that one? Try that one. This single mark here and this single mark there, that means those 2 angles are exactly equal, right? Those angles are exactly the same as each other. So see if you can figure it out from there. All right, what do we think? No on both? No? It's a no? Why? Talk to me on this one, Kendall. What do you think?
Okay, well, I was thinking a little... Okay, so I know it's not congruent.
How do we know it's not congruent?
Because the angle on the triangle that has all 3 sides,
Yeah.
it's in between
Okay.
But if it were congruent and then, or it's facing the 4, but then it's adjacent to the 4 on that side.
Right, or you could just say the one that's across from it, huh?
Across.
Yeah, so across from it's the 4, across from it's 5, that's different, no way they're identical. Good so far, so no way they're identical, because to be identical, everything's got to be the same angles, across from same sides, all that. So yeah, they have different sides across from those same angles, so no way that. How about similarity, though? Could they be similar? No?
No.
Do we know for sure?
Well, I was thinking,
Is there a reason we...
about, like, the scale ratio.
Okay.
And how it'd be pretty much unless like, because the 4 and the 5s, if you try to equal those out, they'd be equal. But if you wanted them to be at least similar, there has to be a scale ratio, and that means the other side would have to be 2 to equal each other, but then that means it's congruent, and we know it's not congruent.
Are you sure it would have to be 2, though? Why, how do you know the other side would have to be 2?
Because what else would this scale ratio be?
So couldn't it be that, like, say this is, I don't know, I'll just make something up, that this is like a 60-degree angle, this is a 60-degree angle. Let me just do a maybe. And then that's the medium. So this would have to be bigger. This is maybe like 80, and this is maybe like 40, because it's the smallest. And then on the other side, this is over here 40, and then this side is 80, because this would be the medium, and this would be the biggest side. I don't know, maybe it's 10 or whatever. I'm just making up numbers. Isn't that possible? And then they would be similar, right? They'd have the same 3 angles, but they wouldn't be. So I think it's just not enough, right? I don't think we can know for sure unless there's something I'm missing. Can you maybe? I mean, Kenny, you might have something there. Could you say that more precisely? I can't think of any way that we know for sure they're not similar, but I could be missing something. Right? Why couldn't that be a possibility right there? Do some of the ratios not pan out? There might be a reason. I can't think of it, to tell you the truth. So let me know if you think of something later. But I think it's just that we don't know. We just don't know enough information about the other angles to decide about similarity. For sure they're not congruent, right? For sure they're not congruent because across from the same angle is different sides. So no way they're identical, but they could be similar because we only know one angle. The other two could be the same or they cannot be. We just don't know. And we just don't know all the sides to be sure either. So it just seems like we don't know on that one. How about number 6? Want to try number 6? See if you can get all the angles in. All right, how we doing? Did you find all the angles in the triangle to the left? So 80 with the 4. This has got to be 80. We good there? Because across from same sides got to be same angles, right? That one's isosceles, same angles, same sides. And so what's the missing angle there? What's this angle? You add the 80 and the 80, 160. So that leaves 20 degrees. So we have that triangle. Okay, so what does that mean? Could they be similar? Could they be AAA? Yeah, no way, huh, Nancy? Why not?
Because the other triangle at 30 degrees.
Yeah, and this one doesn't have a 30-degree angle. So no way they're similar. They already have a different angle. You have to have the same 3 angles to be similar shapes, don't you? And they already, we don't know it a lot, but we know enough to know they don't have the same 3 angles. So for sure they're not similar. They're not the same shape. And are they congruent? To be congruent, you got to have everything the same. All the sides, all the angles. Again, no. We already know they have a different angle. So that one's a no. No on both. This making more sense? Is it getting easier? Good. All right, number 7. Try that one. All right, what's our conclusion? What do you think? Did we find all 3 angles? Triangle on the right? Yeah, what's this angle over here? 40 to make 180 total in that triangle. So we have those 3. So, okay, so are they similar? Do we know AAA? Do we know they have the same three angles?
No.
So what is it? Yes, no, not enough?
Not enough.
Yeah, not enough. We just don't know, huh? We have one angle that's the same, 40 and 40, but we just don't know the other angle, so it's not enough. What about congruence? Could they be totally identical? Yeah, it's another not enough. They could be. The 40's across from the 5, the 40's across from the 5. It's like so far so good. We just don't know enough information, huh? So let's move on. That's just not enough, not enough. Number 8. Try that one. Did you guys notice side, angle, side, right? Side, angle, side. 7, angle, 3. Side, angle, side. They have the same side, angle, side. Remember, what does side, angle, side prove? Identicalness. Congruence, huh? So those two triangles are congruent by side, angle. Remember all those three-letter combos, except for AAA and the bad word. All the rest, they prove fully identical, don't they? So those two triangles are completely identical. So if they're completely identical, are they similar? Oh, yeah. That's like a weaker condition. If they're fully identical, of course they're similar. Does that make sense? All right, 2 more. Hold on. We got 2 good minutes. Let's use them to finish these last 2. I'll talk you through these 2. How about this one? That 7 is in kind of a funny spot. It's that bottom there. So let's get the third angle in number 9 there. What's that third angle have to be? What is it, 120? And 30's 150. Yeah, so it's got to be 30, doesn't it? So it's got to be 30. So what do we know if we have... what else can we do on that triangle on the left? Notice we have 2 equal angles. So what does that mean? The sides across from them have to be equal. It's an isosceles triangle, right? So the 30 and the 30, the 2 sides across from those 30s, the 2 equal angles have to have 2 equal sides. So what is, this one's got to be 7 also, doesn't it? Does that make sense there? Okay, so we know a lot about that triangle. How about the triangle on the right? Can we find out his other? We know this one's a 120, but how can we even find the other 2 angles? Tammy?
Because since both of those sides are equal, both of the angles have to be equal, so they both have to be 30.
These have to be the same, yeah, because that's isosceles also. And so they have to both be 30 because that makes 180. They got to be the same. All right, so are those triangles similar? Do we have AAA? Yeah, for sure. We have the 3 angles the same. Are they congruent? Are they totally identical? Yeah, because they have the same sides across from the same angles. Yes. Last one, number 10. What about that one? What's that 3-letter combo? A-S-S. A-S-S. That's the bad word. So I'm making sure you remember that. That one, what does that mean? Does that mean they're fully identical? Is that yes, no, or not enough? That's not enough. Remember, they could be. Remember, the bad word just means we don't know. They could be identical. They could not be. There's just different options because that's the bad word. The ASS is unknown. And what about similarity? Yeah, again, not enough information. They have one angle the same. We just don't know about the other 2 angles. Not enough information.